I just want to talk about this quick with real data. All right. Because our goal in math a lot of times is to model and create a mathematical model that fits real life data. All right. So maybe you have something when you look at the data, it's linear. All right. And so then you would do linear regression. So that would be y1 tilde m x1 plus b, because you want DESMOS to find the line. Now, if you just always do linear without looking, right? Like if you look at that much, you might be like, oh, that's linear. Well, no, if you look at all your data, this one looks like a reflected quadratic or parabola. So in DESMOS, I would do y1 tilde, and then I think this is going to be like in the ax squared plus, bx plus c form, standard form. So I'm going to do a x1 plus n squared b x1 plus c. So I have it looking like a quadratic. I have x squared x and then the c and then abc. And I want DESMOS to come up with that quadratic equation based on the data. Okay, because it's not perfect, right? It's not like one where there's a perfect vertex that I can find and sub in a point to solve for those things. It's not, it's going to have some things that are off it, some on it, but it kind of overall behaves like that. Okay, but what if your data looks like this? And you're like, well, and again, it's not going to be perfect, but overall, you're like, oh, well, it has two changes in directions or two humps, right? So you're thinking this is a cubic, right? And so then how would I do that? Well, again, very similar. You're like, well, y1 tilde ax cubed, but it's going to be x1 because we're grabbing the data from the chart. X1, what is that? Squared plus c x1 and then plus d, because again, I'm thinking that, maybe that's what it is. And then you kind of look at it and you see, all right. So say we look at this data, right? Okay, so we have hurricanes here. And again, when you're dealing with calendar years, it doesn't make sense to use those. So we're going to use like decade 1, decade 2, decade 3. All right, so I'm going to go ahead and enter this data. So let me go into DESMOS quick. Where am I at? Right here. Okay, so I'm going to hit the plus sign off to the left here, right there. Okay, and so I'm going to enter 1, 2, 3, 4, 5, 6. What are we going to do? 7, 8, and 9 for the I don't want that one, for the decade. And then this is the number of major hurricanes in the Atlantic basin area. So again, I'm just typing these in. 27, 16, 16, 27, and 33. All right. So now, if you can't see them, obviously you can do this. But then again, if your window's kind of wonky, you might not see anything. So I'm looking over here and saying, well, these go from about, 0 to 10. These go to about, 35. So I'm going to come over here and I'm going to hit the wrench. And I'm going to set my X window. I'm going to start at 0 and I'm going to go by 10. And I want my step to be ones, a decade at a time. My output, I'm going to go 0. And then about a little bit past my maximum range. All right, so here I go. So when you actually get it so that the units are kind of matching your data, right? Like you don't want to, I can manipulate data a lot, but when I look at this, I'm like, oh, it curves up. There's two changes in direction. So that looks like it might be a cubic. So I'm going to come down here. I'm going to go y1 tilde. All right, so then I need an a with my x, but it has to be x1 because you want it to gather the data from the chart. And then plus bx1 again, but this time it would go down a power squared. This is going to be a polynomial function, nice and curvy, x1, and then what, plus d. All right. And, again, it's not going to be perfect, but it looks like it models it pretty well. Now, it might be a situation where you limit your domain and say, okay, well, this only makes sense from decade, 0 to decade, maybe 10 or so. All right. Because maybe we notice a change in the amount of hurricanes these days. But so for those times it model it. And then down here, it gives you the coefficients. So you can write it. So you would write 0.39 x cubed plus or minus a negative, what, 5.96 x squared plus 26.20 x plus or minus, depending on what you're doing, a negative or not, negative 7.41. And then what you can do is then you can use that to predict, right? So let me write that down quick. 0.39, we'll just do 2 decimal places, x cubed plus, what do we have? I'll put a negative, I already put my plus, I'll change it to a minus. Minus, what is that? 5.96 x squared, and then plus 26.20x, and then what? Minus 7.41. All right, so let me switch out of DESMOS here and get back to kind of just what I was writing. Okay, so based on DESMOS, this is a polynomial function that kind of models what we think is going on. All right, and we think it's a cubic. Now, again, you cannot say this is going to last for the next 200 years, right? Like, you know, there's changes in behaviors of things right now. So, but I could say, well, you know, this is in the decade 2001 to 2010. Well, okay, so what do I think like is going to happen in what, 2011 to 2020, or what do I think did happen, right? So that would be an input, that's your x, an input of 10. So what you could do then is sub in 10 everywhere you see an x, right? So 0.39 times 10 cubed minus 5.96 times 10 squared. You could put that all in and then get your output, right? And figure out that would be, the output would be the number of hurricanes. And the fact is, we know the data right now because we're in the next decade. So we could see, like, is this still working? Is it predicting what I think is going to happen, right? And again, I don't really think, or at least I hope not, I don't really think that hurricanes are going to go off into infinity. At least I hope not, right? So you know what I mean? It might be valid for a few more years, but then maybe it comes down again, right? And then you're like, oh, so maybe it's to the 4th power, right? So maybe it starts coming down again. So let's say year 10, maybe say that goes up again. So let's say that's, oh, I don't know, 40. Okay. But then maybe the next decade, or not year 10, decade 10, maybe it starts to go down again. And you're like, oh, okay. And then maybe the next decade, it starts to, maybe we see a decrease, right? And so then you're like, well, this does not model that at all. And you are right, it doesn't. Okay, so let's think, okay, well, now maybe it's more like a quartic to the 4th power. So I'm going to change this based on what I see in the graph. I'm like, well, maybe that's to the 4th power. And again, remember your degree and behavior, and I'll talk about that in a second here. This is what, raised squared. Oops, come on. Oh boy. All right, okay, well, let me shift. It doesn't want me to do it. Come on. Why can't I exponent? All right, I'm going to use the keyboard to see if it'll let me do an exponent here. This is squared. All right, I'm stuck on that thing. All right, I'm going to type in the x1, and then we'll square it. No, we're having trouble in River City. All right, so let's do, maybe I'm going to square it first. And then let me go back and put the subscript in there, see if it'll let me do that. Yeah. All right, and then we have what? D, and that would be x1, and then what? Plus c. Okay. So now it looks like maybe what we would call a quartic. All right, and maybe this is going to model it for a while, right? Because I have 1, 2, 3 changes in direction. I think it's to the 4th power, right? Because remember, it's n minus 1 is the number of changes, right? And you see how A has to be negative because it's reflected, right? And so I can kind of see that. So again, you need to look at your data to really decide what you're going to do before you do it. All right, hopefully that helps.